I, Professor Zemaye Ekpete, welcome my students to CC Math CHM 200 Analytical Chemistry 1. And in today's lesson, we'll be considering analytical process. But we want to have a recap of our last lesson. In the last lesson, we studied what is analytical chemistry and who is an analytical chemist. Analytical chemistry is that branch of chemistry that concerns itself with chemical analysis, including the study of development of methods. An analytical chemist is said to be a chemist that has extensive knowledge and understanding of the fundamental principles underlying the method he or she applies. He can modify and where required and devise new ones where necessary. He is capable of having a measurement with very high accuracy. Such a person is considered to be a graduate of chemistry. And that is just who an analytical chemist is. So in the course of our lesson now, we will be considering analytical process. And at the end of this class, the student should be able to understand the steps involved in an analytical process. What are the steps involved in an analytical process? What is analytical process? Analytical process is a systematic, sequential, practical steps which we undertake to get our result from a sample. There are 7 steps involved in an analytical process. 1. We define the aim of an analytical problem. 2. We select and develop a method of analysis. 3. Sample the material to be analyzed. 4. Prepare the sample for analysis. 5. We measure are the desired constituents. 6. Calculate and interpret the numerical result. And 7. We evaluate the result and estimate their reliability. These are the steps involved in an analytical process, and we'll be considering them individually. Step 1. Defining the aim of an analytical problem. You ask yourself some pertinent questions. What is the problem? What needs to be found? What are the qualitative and quantitative steps that will be taken? What will the information be used for? Who will use it? When will it be needed? How accurate and specific must it be? What are probable inferences? And what is the available equipment and the cost involved? Step 2. We select and develop a method of analysis. Selection of a suitable method is very, very important. And you will select a method with high level of accuracy. You select on the basis of the percentage of the constituent of the sample, and you will select on the size of the sample available to you. This step is very important that every good chemist must know how to select a method of analysis. Step 3. Sampling the material to be analyzed. Sampling depends on the purpose of analysis, the nature of the material, whether homogeneous, heterogeneous, gaseous, solid, or liquid. This will form your method of analysis. Step 4. Sample preparation. You check your sample. Is it a solid, is it a liquid, or a gas? Assuming you are working with a solid sample, you have to dissolve your material. You dissolve it first with water, that's a room temperature water. If it does not dissolve, you further dissolve with warm water. Try heating it up. If it does not still dissolve, then your sample may dissolve in non-oxidizing acids, which are dilute acids. If it doesn't dissolve, you will further dissolve with oxidizing acids, concentrated acids, concentrated HCl, concentrated tetraoxosulfuric acid. And if that sample doesn't dissolve, you will further fuse that sample with fluoresces. After then, you will ash, you will digest. You have chemical separation or masking of inferences. You need to concentrate your analyte. Those steps, you are preparing your sample. You need to change derivative, the analyte for detection. And then you need to adjust solution conditions. pH, you add an acid or a base where necessary. Step 4, concatenation. You perform any necessary chemical separation that you need to do. And then you distill, you precipitate, you apply solvent extraction or solvent phase extraction, etc. Step 5, measurement of the desired constants. You need to calibrate your equipment. These equipments are very, very sensitive, so you must calibrate them. You must validate them. And then you check your control and your blanks. And remember, your measurement cannot just be once. You measure in replicates. You measure your constituent with chromatography, with UV vase, with NMR, with mass spectrophotometer, etc. Step 6. You calculate the result and report. Such computations are based on the raw measurement made. Every good analyst has notebook and biro where you record your raw measurements. From that your raw measurement, you apply statistical analysis to it. With statistics, we establish the confidence interval for the mean value, and we report the result with limitations and accuracy information. Step 7 is the evaluation of your analytical result and estimation of reliability. Reliability is measured by determining the overall consistency of the analytical process. How reliable has this process been? And that is the last step of the analytical process. We'll end this class here. I want you to know that in the next lesson, we'll be considering types of errors. Thank you for listening.